On February the 1st, 2003, the Space Shuttle Columbia broke apart over the skies of Texas and Louisiana. 7 astronauts were gone in seconds. But this disaster was not born that morning. It was built over years, inside meeting rooms, inside spreadsheets, inside a culture that had slowly learned to look away from danger. This video breaks down every documented reason it happened. No speculation, no blame games, just the facts and what they cost. These weren't symbols. They were people with routines, inside jokes, and a calendar waiting on the ground. Rick's husband had promised his daughter he'd be home for her birthday. Kalpana Chawla had told her husband the stars were already her address. Ilan Ramon, Israel's first astronaut, had carried with him a drawing made by a child who survived the Holocaust. They were 16 days into a mission that had gone well. None of them knew what was embedded in their left wing. Reason 1. This failure did not begin on the day Columbia launched. It began decades earlier, the moment foam shedding was first observed and treated as a nuisance rather than a warning. 81.7 seconds after launch on January the 16th, 2003, a 1.67-pound piece of foam insulation broke off the external tank's left bipod ramp. It struck the leading edge of Columbia's left wing at an estimated 545 miles per hour. That impact created a breach in the reinforced carbon-carbon panels, the thermal armor protecting the wing from re-entry heat. NASA engineers had observed foam shedding on at least 65 of 79 previously filmed shuttle launches. Each time it happened and no disaster followed, the risk was quietly reclassified as acceptable. The institution stopped treating the problem as a problem. Foam had struck Columbia's sister orbiter, Discovery, on multiple missions. Reports had flagged bipod ramp foam as a concern. Those reports never triggered action. Each survived flight became its own justification for ignoring the next warning. On its own, this strike was survivable, if anyone had been looking. The next failure made sure no one was. Reason 2. The foam did not scratch the surface. It punched through it. The scale of what happened to Panel 8 is something NASA did not fully reckon with until it was too late. The foam strike created a breach in reinforced carbon-carbon Panel 8, measuring approximately 6 to 10 inches in diameter. During re-entry, plasma at temperatures exceeding 2,700 degrees Fahrenheit, roughly 1,480 degrees Celsius, entered through that opening. The aluminum wing spar, which was never designed to touch those temperatures, melted. Structural failure was irreversible within minutes. This was not a slow degradation. The wing was being destroyed from the inside. But because no one had confirmed the breach existed, no one was watching for it. The crew flew a re-entry into a wing that was already failing. Sensor data during re-entry showed abnormal temperature readings inside the left wing more than 8 minutes before Columbia broke apart. Those readings were transmitted to the ground. The CAIB found that no decision path or emergency authority existed within the mission control structure to act on anomalous re-entry sensor data in real time. The physics were already decided. What could still have changed the outcome was a decision made days earlier, a decision no one made. At this point, the mission wasn't normal. It was a countdown nobody could see. Reason 3. After launch, NASA engineers saw the foam strike on footage. Some of them were afraid. What happened next is where the institutional failure becomes personal. Launch imagery analysts identified the foam impact within days of liftoff. Boeing engineers formally raised concerns about potential wing damage. 3 separate requests were submitted through official channels, asking the Department of Defense to use satellite assets to photograph Columbia's wing. Each request was either denied or quietly withdrawn by NASA management before it could be fulfilled. Senior shuttle program managers concluded the crew was not at risk without obtaining the evidence that could have confirmed or disproved that conclusion. The Columbia Accident Investigation Board later described this as a decision made in the absence of data, dressed up as confidence. engineers sent emails expressing concern. Those emails were not escalated. One analyst described being told, in effect, that raising the alarm was not welcome unless she could definitively prove catastrophic damage, a standard of proof no one could meet without the imagery that was being refused. This was the moment rescue remained possible. Once it passed, the outcome was sealed. Reason 4. When engineers tried to model the damage, they reached for the closest available tool. That tool was built for a completely different scale of problem. Boeing engineers used a software program called Crater to estimate the damage from the foam strike. Crater was designed to model micrometeorite and small orbital debris impacts, objects weighing fractions of a gram. The foam piece weighed 1.67 pounds. Engineers extrapolated results far beyond the tool's validated range and concluded the damage would be, quote, not a safety of flight issue. The CAIB found that no one in the decision chain stopped to verify whether Crater was even appropriate for an impact of this size. The tool's limitations were documented. They were simply not consulted. A conclusion drawn from a broken analysis was treated as authoritative engineering judgment. At least one engineer flagged that the model was being used outside its validated range. That concern was not escalated. It was absorbed into an institutional momentum that had already decided the answer was safe. The analysis said safe. The analysis was wrong, and nobody was required to prove otherwise. Reason 5. The most dangerous thing that can happen inside a safety-critical institution is not a single catastrophic failure. It is the slow, quiet decision to stop treating small failures as warnings. Over the shuttle program's history, known anomalies, foam shedding, tile damage, O-ring erosion, were repeatedly observed, failed to cause immediate disaster, and were progressively reclassified from safety concerns to accepted program characteristics. Each survived flight reinforced the assumption that surviving was the same as safe. The Columbia Accident Investigation Board applied sociologist Diane Vaughan's concept of the normalization of deviance, the process by which organizations gradually come to accept behavior that should remain unacceptable. The board identified this as a root cause of the disaster, not a contributing factor. The system had been teaching itself that risk was normal. Every foam shedding event that did not kill anyone made the next foam shedding event easier to dismiss. By 2003, the anomaly was so normalized that the burden of proof had been reversed. Engineers now had to prove danger, not management proof safety. This mindset had been building for 17 years. It had already killed 7 people once before. Reason 6. NASA had a safety reporting system. On paper, it existed. In practice, it had been structurally defanged over years of budget pressure and cultural drift. The CAIB found that NASA's safety office lacked the authority to halt a mission or compel an investigation. Safety personnel could raise concerns, but they had no mechanism to force a response. The system was designed to be heard, not to be acted upon. During the STS-107 mission, engineers who raised concerns found their emails filtered, their requests deprioritized, and their warnings absorbed into a chain of command that had already reached its conclusion. The board described this as an institutionalized silent safety program, a system that performed the appearance of safety culture without possessing its substance. Individual engineers acted responsibly. The institution failed them. After the mission, investigators found a trail of emails from engineers who knew something was wrong, who tried to say so, and who were either ignored or told their concerns did not meet the threshold for escalation. Those emails are now part of the accident record. The people who should have stopped this tried to stop it. The system that should have amplified their voices silenced them instead. Reason 7. The erosion of NASA's safety culture did not happen overnight. It was the result of a decade of funding decisions made far from the launch pad. The CAIB found that between 1992 and 2002, NASA's budget was reduced by approximately 40% in real terms, a figure the board cited directly as a structural contributor to the accident. The reductions fell disproportionately on safety, reliability, and quality assurance functions. Experienced engineers were retired or reassigned. Institutional knowledge was lost. Meanwhile, the shuttle was being repositioned as an operational vehicle to support International Space Station construction, a schedule NASA was politically and contractually committed to meeting. The CAIB concluded that schedule pressure and resource constraints had become woven into management decision-making. Missing a launch window carried institutional consequences. Raising a safety concern that delayed a mission carried a different kind of consequence for the person raising it. Independent safety assessments conducted in the late 1990s warned that NASA's safety infrastructure was being degraded. Those assessments did not change funding priorities. The warnings were filed and forgotten. Budget decisions made in Washington shaped what was possible and what was survivable in orbit. Reason 8. One of the most striking facts about the Columbia disaster is that the tools to confirm the damage existed. The protocol to use them did not. NASA had no standing, mandatory procedure requiring high-resolution imaging of the shuttle's thermal protection system after launch. The U.S. Air Force and the National Reconnaissance Office operated satellite assets capable of photographing Columbia's wing with sufficient resolution to assess damage. None of those assets were tasked. An informal request that was initiated was withdrawn before it was fulfilled, apparently because management had already decided the crew was safe. The CAIB called this a significant missed opportunity and recommended that all future shuttle missions include mandatory post-launch imaging. That recommendation was implemented. It came 17 days too late for the crew of STS-107. The absence of this protocol was not accidental. It reflected an institutional assumption that phone strikes were cosmetic events that did not warrant investigative resources. That assumption had survived dozens of missions. It did not survive Columbia. The photograph that could have saved 7 lives was never taken, not because the camera did not exist, because no one was required to point it. This is the part that hurts. The picture could have existed. Reason 9. Even if the damage had been confirmed on day 1 of the mission, NASA had no practiced, ready answer for what to do next. NASA had no operational capability to repair thermal protection system damage in orbit. No on-orbit repair procedure had been developed or rehearsed for the reinforced carbon-carbon panels. Critically, Columbia could not have reached the International Space Station as a refuge. The orbital inclination difference between Columbia's 39-degree orbit and the station's 51.6-degree orbit would have required a propellant budget the shuttle did not carry. The only theoretically viable rescue option was launching a second shuttle, Atlantis, to Columbia's existing orbit. The CAIB analyzed this scenario in detail and concluded that under optimistic assumptions, a rescue mission was physically possible, but only if NASA had recognized the danger immediately. The board wrote that the crew of STS-107 did have a chance to survive had NASA recognized the danger in time. The absence of an on-orbit repair protocol was a program-level planning gap that had existed for years. No one had been required to close it. After Columbia, NASA developed and tested repair materials for all subsequent missions, a direct acknowledgement of what the absence had cost. 7 people were in orbit for 16 days. With early recognition and a prepared plan, some of those days could have been rescue days. They were not. Every day they waited didn't just reduce options, it erased them. Reason 10. The most haunting finding in the entire Columbia investigation is not what went wrong. It is that everything that went wrong had gone wrong before and been formally documented. In 1986, the Space Shuttle Challenger broke apart 73 seconds after launch. 7 astronauts were lost. The Rogers Commission identified the root causes. safety warnings ignored under schedule pressure, a culture that suppressed dissenting engineering voices, and anomalies that had been normalized over years of flight. NASA implemented reforms. Then, across the 1990s, through budget cycles and leadership changes, and the slow accumulation of successful missions, those reforms eroded. The Columbia Accident Investigation Board drew explicit, documented parallels between the two disasters. It concluded, the causes of the institutional failure responsible for Challenger have not been fixed. 17 years, two crews, the same failure, rebuilt from scratch inside the same institution. The Rogers Commission report was public. Its findings were part of the institutional record. NASA's own safety studies in the late 1990s had warned that the culture was drifting backward. Those warnings did not produce lasting change. They produced the next accident. This was not ignorance. This was forgetting. And forgetting inside a system this complex costs lives. Reason 11. The piece of foam that destroyed Columbia was not a defect in the manufacturing line. It came from a section of the external tank that was shaped by human hands and had been flagged as structurally unreliable for years before the accident. The bipod ramp, the foam wedge that shed the fatal debris, was not molded or machine-applied. It was hand-sprayed and hand-shaped by technicians at the Michoud Assembly Facility in Louisiana. Because it was formed manually, its internal structure was inconsistent. It contained voids and stress fractures invisible to the naked eye. When the shuttle experienced aerodynamic and cryogenic loading during ascent, those hidden weaknesses gave way. The CAIB found that the bipod ramp design was an engineering workaround, added in the 1970s to solve a structural problem that was never subjected to the same rigorous failure analysis as other shuttle systems. NASA had identified the bipod ramp as a foam-shedding risk on multiple occasions. A formal redesign had been discussed, but never funded or prioritized. Each year, the ramp survived without causing a disaster. The case for redesigning it weakened. The CAIB concluded that the decision to leave the bipod ramp in its original configuration, despite known foam liberation events, was an unresolved engineering hazard that the program had simply chosen to carry. Foam debris from the bipod ramp area had been photographed on previous missions. Post-flight inspections had documented it. Internal engineering reviews had flagged it. The ramp was on lists of known concerns. It was never on a list of resolved ones. The piece of foam that ended 7 lives was shaped by human hands, and the decision to leave it unchanged was shaped by human choices. The danger was never hidden. It was just never fixed. Reason 12. Every other American crewed spacecraft before the shuttle, Mercury, Gemini, Apollo, carried a launch escape system, a mechanism of last resort. The shuttle did not. That was not an oversight. It was a deliberate design decision made in the 1970s that was never revisited, even after Challenger proved it mattered. During the shuttle's development, engineers and program managers debated whether to include a crew escape system. The shuttle's design, with its side-mounted orbiter, solid rocket boosters that cannot be shut down once lit, and glide-only landing, made a traditional escape tower impractical. A decision was made to accept the risk. The result was a vehicle in which, under certain catastrophic failure scenarios, there was no survivable exit. During re-entry, there was none at all. The CAIB noted that even if damage had been confirmed during the STS-107 mission, the crew had no independent means of escaping a compromised vehicle on the way home. After Challenger, NASA studied crew escape options and implemented a limited bailout pole system, usable only during a controlled glide at low altitude when the orbiter was already in a survivable flight profile. It was never useful in the scenarios that actually killed crews. The CAIB found that NASA had not seriously revisited the question of crew survivability in the context of re-entry damage scenarios. The program had designed around the assumption that catastrophic TPS failure would not occur, rather than planning for what to do if it did. The Rogers Commission, after Challenger, had raised questions about crew survival philosophy. Post-Challenger modifications improved abort capabilities in narrow windows during ascent. No equivalent investment was made in re-entry survivability. The institutional assumption remained: if the shuttle is damaged enough to fail on re-entry, nothing can be done. That assumption was never formally challenged, until Columbia made challenging it irrelevant. 7 people flew home inside a wing that was already failing. There was no door they could open, no system designed to bring them back if the heat shield was gone. In the end, the shuttle had no answer for the one failure that actually came. Look across all 12 of these failures, and a single pattern emerges. Not one of them was invisible. Not one arrived without warning. The foam had been shedding for years. The bipod ramp had been flagged for years. The safety office had been raising concerns for years. The analysts had the tools. The satellites had the cameras. What failed was not technology. What failed was the institutional will to act on what was already known. This is how major disasters are built. Not in a single catastrophic decision, but in hundreds of small ones, each one survivable on its own, each one teaching the system that the shortcut is safe until the day it is not. Sociologists call this normalized deviance. The Columbia Accident Investigation Board called it a root cause. Historians call it a pattern because they have seen it before. In Challenger, in Chernobyl, in every system that grew too comfortable with its own near misses. The specific technology changes. The organizational behavior does not. That is why disasters like Columbia do not stay in the past. They migrate forward into whatever system stops paying attention. 7 people launched into orbit on January the 16th, 2003. They were scientists and pilots and explorers. They had families waiting. They had no idea what was already broken in the wing below them. Disasters are not events. They are processes. They are built slowly and quietly inside the systems we trust to prevent them. Columbia is proof of that. So is Challenger. So is every accident that is still waiting to happen inside a system somewhere that has convinced itself the warning signs are acceptable. The question is never whether the warnings are there. They always are. The question is whether anyone is still listening.